So let's solve some equations with fractions. Solving equations with fractions. Okay, so the first one I'm going to do, I'm going to use a method you might already know. So let's say, for example, I have 7x divided by 4 equals 3. So here I have an equation, got a fraction. This equation is just one fraction equal to a number. So one strategy I could use on this is cross multiplying. So if I just put the 3 over 1 and then cross multiply, I'll have 7x times 1 is 7x, 4 times 3 is 12. Divide both sides by 7, and I'll get x's, I could just leave it as 12/7, or if I want it as a mixed fraction, that would be 1 5/7, or if I wanted to do a decimal, this is about 1.71. Okay, so depending on how I wanted it. So when I have one fraction equal to another fraction, my normal cross multiplying, or a fraction equal to a whole number, I can just cross multiply. Now the ones we're going to focus on though in this video is more like this. So if I have more than just one fraction on each side, my strategy is to multiply each term by the least common denominator over 1. Okay, for short, I'm just going to jot down times the LCD over 1. So we'll see why we use this strategy when we do an example. So the first one we'll do is x over 5 minus 8/3 equals 2x plus 1/3. So using the strategy of multiplying by the LCD over 1, I'm going to do this to each term. So first of all, I'm going to look and I'm going to count how many terms I have. 1, 2, 3, 4 terms. So remember, terms are separated by equal sign or pluses and minuses. So now I'm going to look at what my least common denominator is. My denominators are 5, 3. This one, I guess we think of it as 1. There's nothing there. And 3. So between 5 and 3, my common denominator is 15. So I'm going to take each term times 15 over 1. So 15 over 1 times x over 5 minus, so I'm going to change that to red, 15 over 1 times 8 over 3 equals 15 over 1 times 2x, or to make it look like a fraction, I'm going to do 2x over 1 plus 15 over 1 times 1/3. So again, let's do a little check. We had said 1, 2, 3, 4 terms, and I'm doing this 1, 2, 3, 4 times. I'm multiplying by 15 over 1. It's important that each term is multiplied by the same thing. Especially be careful when you have something that doesn't look like a fraction, like the 2x, this still needs to be multiplied by 15, or 15 over 1. Okay, so now let's look at what happens. So what is going to happen when I multiply? Remember, multiplying fractions like this, I can do some reducing. 15 and 5, I'd be down to 3 and 1. So I'm left with 3 times x is 3x. Okay, or instead of reducing, I could have done 15 times x divided by 5. 15 divided by 5 is 3. Same thing here. I could do 15 times 8 divided by 3, or do some reducing down to 5 and 1. So 5 times 8 is 40. equals. Next one, nothing to cancel. 15 times 2x is 30x plus my last one. I'm going to reduce the 3 and the 15 down to 5 and 1, and I am just left with 5. Okay, so notice the reason I multiply by the least common denominator of 1, when I did that reducing, see how everything on the bottom just ended up being 1s. So we're doing this to drop out our denominators, and now we have an equation we can solve that doesn't have any more fractions in it. It'll make it a lot easier to solve. Okay, so from here we could just do our normal equation solving steps. I'll subtract 3x on both sides. And then at the same time I'm going to subtract 5. Kind of combine those two steps. So I'll have negative 45 equals 27x. Divide by 27. So x is, let's see, that's going to be a negative. Well, if I did this, if I reduced by 9, that'd be negative 5/3. Or that'd be negative 1 2/3. Or negative 1.67 if I were asked to find my answer to the nearest hundredth. Okay. So, and just like normal, I could plug this in. Since I'd be plugging in a fraction, or a decimal in a fraction, you might want to just kind of estimate what is this side, make sure it's approximately equal to this side. It might not come out exactly right, but should be approximately the same thing on both sides if I got the right answer. Okay, let's do one more. Now this one, the difference, it's going to be one difference. So this one, my equation that I'm going to solve is 1 over x plus 3/4 equals 15 over 6x. So this one, the difference is now I have some x's in the denominator, but I can use the same strategy. So I look at my denominators, x, 4, 6x. X, 4, and 6x. So my common denominator, well, just between the numbers 4 and 6, I could use 12. If you're thinking 24, that would work as well, but the least common denominator would be 12. If you did 24, you're going to still get the right answer in the end. You just, in the meantime, we'll deal with some bigger numbers. So, but 12 would be the least common denominator between 4 and 6. And then I also am going to have to multiply by x. So every term I'm going to do 12x over 1. So 12x over 1 times 1 over x plus 12x over 1 times 3/4 equals 12x over 1 times 15 over 6x. So just like the last one, let's do some reducing. In the first set, x is going to cancel, and I'll be left with just 12 times 1, so I'm going to bring down 12. Next one, 4 and 12 reduce, and I'm left with 3. So 3x times 3 is 9x equals, my next one, the 12 and the 6 reduce, I'm left with 2 on top. X and x cancel out as well. So I'm left with 2 times 15, 30. Okay, so this, by multiplying everything by 12x, each term, all 3 terms in the equation, I'm now left with the equation with no fractions. So I'll solve it. So I'll subtract 12. 9x equals 18. Divide by 9. And x equals 2. So this is one we can, I'm going to check this one. Let's check this one out. Good fraction practice. So it should be correct if I have 1/2 plus 3/4. So that should equal out to 15 over 6 times 2 is 12. So this is 2/4 and 3/4, which is 5/4. Should equal out to, and I'm just going to bring this down, reducing 15/12 by 3. I would, yes, be left with 5/4 on both sides. So this checks out. X equals 2 is my answer.